bench. And let's wait for the audio to arrive. And once the audio arrived, we can start the stream. So, yeah, audio is there. So today, an impromptu stream, and I found an idea. In the previous streams, we got this battery working. Basically, yeah, just watch the previous stream to know what it does. Well, it's a huge battery, which somebody gave me, and it is now working. The problem is I had no idea what to do with it. I did it activated. It's 48 volts nominal up to 55 volts, and I had no idea what to do. So the first thing that's important was to have something to step it down, and I've built, so you can use it, for example, for 12 volt battery or something like that, else it's completely unusable. And I built this. This is to step down the voltage. You see this connector, that's how you're doing. I'm using US plugs. Here, these are US plugs. These are just car spade connectors, I think they're called. And I can actually plug it into this connector. Let's plug it in. Up. Now it's plugged in. Oh, it was already on. Okay. I added a switch to switch it on and off. And if you switch it on, then I have this high voltage transformer, which can have up to 75 volts input. And then you can step it down to any voltage you want. Well, almost any voltage, between 2.5 to 50 volts, which is around here. And at least I could use this battery for something. And the problem was that I still had nothing which is reliable, and somebody told me, well, if you have a lot of energy, how about you put it into smoke? And the idea behind that is to build a portable smoke machine. Now, you could have portable smoke machine like an e-cigarette, but it doesn't produce a lot of smoke. We want something which is dance floor ready, or festival ready, or something which is big. So I decided to do that, and I just got a smoke machine for a really tiny one, just to test it out. It's super cheap. I got it for 30 euros. And what we'll try to build is a portable smoke machine using this battery, because putting smoke out requires a lot of energy, but this has a lot of energy. And that's what we're doing. So let me switch this off, because while this was the working really prototype with hot glue and broken US plugs, which works, I've built something better. And this is that. If I open it, we can see that this is my, let's put it this way, Kirudu RP-H002. That's the battery model, and this is a connector. And the idea behind it is that you would plug this here, and it fits nicely in. And this would allow you to easily connect. So this would replace this, which is a bit more professional. So I had this PCB made, and I didn't get the spade connectors yet. I ordered it at the same time, but they didn't arrive yet. So the spade connectors, these are on this side. You put them here, and they replace the US spades like this. Let me keep this here. These kind of tabs, and you can have board-mounted tabs instead of these US plugs. But I didn't receive them. Nevertheless, I was able to build one of them. This is what you see here, and I cheated. I didn't use, because I didn't have them, the tabs. What I used are spade connectors. Or I don't know how they call. I'm calling them spade connectors from the automotive. And I used these things. I just removed this back cover. Here you have a piece of metal, and when you unfold the metal, this is what you're doing. Here, this is what you see. It fits perfectly the hole, and then on the other side you have a metal piece. until I receive the tabs, this is at least a prototype. And the advantage is that I could use it and it actually works. So let's plug it in. Yeah, the output is on off. Let's plug it in. So it's not meant to be plugged in and off all the time because these are not the right connectors, but once it's in, there's no reason to remove it. Up. And here, yeah, there was a short on, simply because it sends something, but it's not completely on. There's a switch for that. And you can have directly the output here. I used a mains thing to have an output. Now we can switch it on. This is the port to charge. This is to switch on and off. And what I've decided to do is, here you see there's a CAN connector. Whoop. There's a CAN connection. What I didn't know when I designed this is that you need CAN to fully activate it. If you just switch this on without the CAN, you will, let's switch this on. You see that the other LED is not on anymore. Let's switch it off again. This fades, you switch on, the output is on, but actually on the battery plus battery minus, you are limited to only 1 amp. What you need to do is send CAN messages to completely activate it, and I didn't know it while I was designing that. I knew it only before, so I made a redesign, but at least using the prototype, I can still prove that it works. And there it is. Now when I send the CAN messages, it fully activates the battery, and this makes the charging port also on. The charging, this red LED here was only meant to indicate when the port was charging. But it seems that when the battery is fully activated, the voltage on the battery plus and the charge minus is also at the battery level. This is why this red LED right there is activated. And then on the back, we have a step-down converter. Buck step-down converter. This is only 200 watts, but it was plenty sufficient. The other one was 600 watts. This is 600 watts. I think I wrote it. Yeah, step down 600 watts, 25 amps. This is only 200 watts, but it's a lot smaller. It doesn't have a fan, and it's plenty sufficient for what I'm doing. And this is also providing the 12 volts for this module. Here we have another step-down converter from 12 volt to 5 volt, which is powering the board and the CAN transceiver, and this board is then injecting the CAN messages. So now we have a battery where we can draw plenty of energy. Let me switch it off, and we will try to actually see if it's good enough for powering this thing. So let's open this. Let's put the battery on the side because we won't need it for now. Up. Check. And let's open this. I barely opened it just to make the small preview, the thumbnail, but I didn't test it, and I don't know how they work, so we will have a look at it. There's not a lot into it. It's not a review of a smoke machine. We will tear it apart and we'll use it. And there's no need to... Why is it French? Smoke machine? Machine, I don't know. Yeah, nothing enough. 400 watts. I think the battery can develop 400 watts, no problems. It's not a big smoke machine. It's a tiny smoke machine. I'm sure there are smoke machines with 2000 watts and so on. We wanted to make it portable, and 400 watts should be plenty sufficient. So we have this. Okay, this is to fix the smoke machine on something. We'll probably use it once we fix it on a backpack. Let me zoom a tiny bit. USB plug. Plug in. This is probably to switch it on and off. And these are the screws for the mounting bracket. We want to use the mounting bracket. Yep. So it doesn't come with smoke fluids, but luckily at the club I'm working, or the bar I'm working, they had smoke fluids, and I just stole a tiny bit of it. Well, it's not stealing. I asked for it. Here it is. And here we have smoking fluids in a drink bottle. So let's try it out. Actually, I can just plug it inside. I can just put it inside here. It's too short. I don't want it to. Is it too short? Yeah, it's too short. Let's put a tiny bit inside there. And we only want a tiny bit. That should be enough for testing. So let's test if this works. And let's test if it's 400 watts. So we will have some power. Let me get a power meter. Up. Here we have a plug. Power meter. And this is using actually XLR. Well, without shield in the end, but at least XLR is a very robust connector. Here, normally, when it's a metal shielded, this is not metal shielded, this is just a piece of plastic. And actually, how do they do that? They have one button and 2 LEDs, but they only have 3 pins. There must be one ground, 2 LEDs. How does the button work? Does it switch off an LED? Well, we'll take it apart and we'll have a look at it. And let's close that. Okay, on the end they wanted to make a level meter. Oh no, you can see. You can barely see the liquid level here. You can't because I'm tilting it, but you can actually see the liquid level. IC connection with a plug. So we'll plug it in. This way, there's a switch, a rocker switch, so let's switch this one on. It boots 0 watts, and if we switch this on, it should draw 400 watts. Yeah, a tiny bit more, 450. I don't know what the rating is or what the limit of the rating is, but having like, it's 1/8. Yeah, 1/8 difference, meaning 12% difference is above 10% difference. It's quite high, but yeah, 450. And here we have no LED going on right now, so I think while it is getting warm, there's no indication. There's probably an indication when the LED is ready, and then the other LED when it's switched on. I don't know. Yeah, this is getting warm. We'll see after what's inside. For now, I just want to test if it works. It is drawing some energy. What I will also do is open the window of my flat, close the other door, and actually disable the smoke alarm, because I'm sure the smoke alarm is actually just detecting particles and not if it's actually smoke or not. So let me try to get this alarm. It might ring when I disable it. No. Okay, it's not meant to be removed, is it? No. How does it work? Else I'll just put the plastic back. Ah, here. Okay. Whoop. That's the smoke alarm in my building. I'm sure it works. I don't want to test it. I'll just put it, yeah, it should work for 10 years. I'll just put it in another room for now. Up, up. I'll put it back on afterwards. At least it's essentially connected. Ah, red. Red means probably it is warm. Yeah, it is actually warm. Draws nothing, so it's ready. Well, it should draw a tiny bit, but for the rocker switch and for that. But it's less than 0.1 watt. And if I press on the button, we should see some smoke going out. Oh. Okay, initial pump. Okay, it works. There is plenty of smoke. It spits out, but it does work. Yeah, smells like smoke, but smoke machine works. Good. Let's take it apart and let's see how it works. Power off. It's the most important thing. Can even unplug, although we don't need to. We'll just unplug. There's no need to unplug anything. But still, let's see inside how the smoke machine is. My assumption is that there's a heating element, there's a pump, switches, and that's it. Thermo switches, but we will see inside this machine. And not a lot of screws. I'm sure they're all the same screws. I just have to pay attention that this is warm on the touch. So now the question is, this is for 240 volts AC. Can I put 48 volts directly, or do I need 240 volts? We will see how it works. Yeah, they're all the same screw. And at least for this price, for 30 euros, this is a mass market device. And it's bare bones. I don't think it has a lot of components and a lot of intelligence. We'll see. Up. Let's go. No, this screw is tight. I probably should take a bigger screwdriver. Okay, that's done. Last one. The one which was tightly on there. Okay, so let's open and let's see inside how it... okay, we need to open this. This is this meant to be a filter? Just a tiny bit of plastic. Is there something inside? It doesn't look like it's so light with plenty of holes. I'm not sure what this is meant to be. Why not just having a tube directly? Is there something inside? I don't want to break it because it works. Yeah, maybe it's meant to be a filter for huge... okay. The tiny holes are just filtering the huge particles. Oh, it's ridiculously simple. Wow, it's really ridiculously simple. So, what do we have? We have... Let's zoom a tiny bit, although there's not a lot to zoom. Here is the input. It's going to the rocker switch directly. This is good. It is... Is this fused? Yes, it is fused. You see on the side the... it's hard to see, but there's the connection. So there is a fuse inside here. Do they put the right fuse for 400 watts, or do they put, meaning 2 amps, 5 amps, or do they put a generic fuse? That's the fuse. We don't have any spare fuse. That's not an issue. What kind of fuse do they put? 5 amp. Yeah, 5 amp would be 2500 watts. No, that's 10 amps. It would be 1000 watts, even a bit more than 1000 watts. But at least there's a fuse, and it's okay. 1000 watts for that. It's a glass fuse, it's not a ceramic fuse. It's simple, but it does provide power. So it's going to this rocker switch, but only one side, or both sides? Only one side. Which one? It's the live. It should be the live. The live should, yeah, goes in there, and then they're using blue wire. Or it is still live? That's weird. Why do they do that? Yeah. Brown wire live goes in the rocker switch, but afterwards the other wires go out. They mix and match cables how they want. So we have a rocker switch. Why do we have 2 positions? Then we have the blue wire, which is the neutral, and we need the blue and the... Do we need it? Does this rocker switch need also the blue to light up? I thought it was only lighting up when current was passing through and not using voltage, but maybe not, because here there's a blue wire which is going directly, so there's the neutral which is going there, So it probably needs that, and the neutral is directly diverted to this thing which has brown wires, although it shouldn't be brown, it should be blue because it's connected to blue, and this goes once to this fuse, and it's not in series, it's in parallel to 1 and 2 switches, and then no, actually, why? That's the other way around. Okay, it goes to 1, 2 here, then it goes back to here to this, but okay, I don't get it. Oh, we don't care. It's parallel again. This is just very probably just a block of aluminium with some insulation and or any metal and some heating resistor. This one, which is still warm, and then these are 2 thermo fuses. I don't know why 2, why only 1? Ah, this is probably the one which is protecting if it gets overheated. This is the one which knows when it is warm enough. Okay, so I get the point. Although, no, I don't get it. How does this work? What I'm wondering though is that on this connector here, we are directly live, although it's not too, I'm not sure what the regulation is. So here we have live pins. Yeah, it's not metal pins. You have to insert something, so it's not more dangerous than any plug, although there's no child safety. This is the male version with the pins, but this is switching live. I don't want that. I will change that. I will have a relay or something like that inside here, because I don't want the remote to be live in my end thing, in my end device. The remote will be somewhere in my hand and hanging around, not probably securely. So this won't be live. We will change that and we will put a relay or I don't know what. Yeah, relay probably. We'll have to figure out how this works though. So why do we have 3 wires? Ah, the switch and the LED. Did the green LED work actually? Does the green LED work? Let's open it. Let's see what's inside. Oh, there's a magnet. Yeah, that's nice. There's a magnet on the back to switch to metal pieces. Let's see inside here. I will come back to this to figure out how this works. And actually, these are 2 different ones. One is normally, we'll see afterwards. And here, yeah, there are 3 wires. Come on, come out. This is switching mains. When you press, there is no, what's latching it behind? Oh, okay. So now I won't be able to remove it because it's soldered after it's put in. So I won't be able to remove it. But what we see is that this brown wire comes to both LEDs. I'm not sure if they're mounted the same way. Then through a resistor, and through the resistor, then here live on. Ah, so when I press on the button, actually the other LED is activated, and this only gets juice when there's power. Yeah, this connector only gets power when it is ready. That's weird. Well, it's weird. No, it's okay though. So did we see it green? Let's connect it. Let's just not touch the bottom, and let's test it again and not touch the inside. This is exposed now and there might be some power. Let's connect it. Here, no, this is off. We will put a tiny bit of liquid so it still pumps something. If it's long enough. No, it's not long enough. Who cares about what it pumps? We don't want smoke. We can have the pump. I don't think, no, it has no detection if it pumps something or not. So let's switch power on. Let's put it back here. So I won't be able to see it. Let's switch this one on. Okay, it draws 450 watts, 450 watts. And there is nothing which is lit up. So I think there is no power which is going through here yet. And probably the power is going once it reaches a temperature. So this you are not seeing. I'm just being aware because this is live. This switch is probably making click when it is hot enough. I don't know how hot it is. We'll see afterwards. We will unmount it. But why? Ah, it made a flash, so it did click. Now this is enabled, and then I press on the button. Does it actually put the other one on? Yeah, that's it. When I push the button, it enables the other LED to say we are sending power. This is how it works. And there was still a tiny bit of liquid inside. So now we know how this works. Let's switch off, and let's understand how this works. This must be enabled. This must have power all the time. How does it? Is there a third one? No, it's the same. This must have power all the time to switch on. No, not all the time. It must have power until it is warm. So when this one clicks, oh, I'm losing screws. When this one clicks, it should turn off. Sorry. I'm talking too much. We know how this works. We can actually put it back, and this is what we see here. There is always power here, which is switched here, and then it's switched back to the yellow once we press on the button, or the other way around. Yeah, there's always power between the yellow and the brown, and when we press on the button, it goes to the blue, which activates only the pump, this pump here. Easy, but clever. And so let's figure out how this works. Let me cut this. I'll put it back on, but it will allow me to better understand the wiring. Let's not cut a mains, but just this strip, this cable. Okay. Now we can better see what it's doing. So we have power going here. In parallel, it is going here, then it is going to the blue. This is the remote. And it is also going to the pump on one side. This is this red wire. This red wire is the pump. And here, oh, there's actually... Is this a fuse? Is this a connection? What it is? Why do they add here something? I don't know what this crimp is. Here, this is not a straight cable. Is there a resistor in line to limit the current? That's a good question. It isn't. Yeah, it is earth. Here we have an earthing pin, so this is earth. This is, the pump is not directly earth. You see that we have the pump plug, but the pump is screwed with metal screws, anodized metal screws, which you see here on the chassis, and the chassis is connected to earth. So it should be good enough. We'll test it if it's good enough, because anodized screws are not perfect, but let's see. Resistance between chassis and pump. Yeah, it's not that great. This should also be ground. And you're not seeing. Why are you not seeing the multimeter? You should be able to. Why is this not connecting or not updating? Let's check that. Okay. Wrong one. SVG. Connecting. Okay, let me restart my bench connections, and now you should be seeing it. So this is directly ground. If I connect to ground here, oh no, it's fine. 1 ohm. So the pump is also grounded, although it's not that important, but the pump is also grounded. I'm seeing something here which is important. 2 things actually which are important. But let me understand how this works though. 1, 2, 3, 1, 1. So the rocker switch enables power. What does it enables power between? Let me switch this off. Let me understand how the rocker switch works. Here. Between this and this, it is off. Then it is on here. So yeah, it enables when this is enabled, it enables power here. So it goes here, comes back here. What is this for? Ah, I get it. But this is dangerous. Is this how it's meant to be? What I miss? No, it isn't. Oh, this is just an indication. Right, so power is going through here in this tube. Here it is connected on this side, and this is connected back to live. So it is getting power through here. This is probably normally open until it reaches a temperature, then it closes. So it stops current from flowing through. We'll see afterwards. And this is normally closed. And when it reaches the too high temperature, when this box gets too high, it's probably then open. We'll test it afterwards. I'll just let cool this after this thing. Okay, so what happens is that here, why does it go here? Do I have to write it down? Oh, if it doesn't flow here, it can still flow through here. So it always flows through the wire. We always have one wire which is connected. And then this goes, this is the pump. And this is, there are 2 things on the pump. 3 things. And the pump, okay, so this is everything which is on neutral. So the pump is controlled using this wire. So when this is enabled, power goes through here. It goes through here while it is heating up. And this is, yeah, this is neutral again. And once it stops heating up, it doesn't go through neutral, but it goes through this wire. But it always goes through this wire also. Maybe this is a tiny bit higher resistance than this path, so it doesn't go through here. but once it stops going through here, but it means that this is always live. This is always live. But it's only activated when this is off. Can we press on the button while... Can we press on the pump while it is still heating up? Probably. We'll try it out. Up. Let's put this back together. We saw what's inside. Up. If I don't understand it, I'll just write the schematic now, afterwards. So let's enable it and let's see if we can pump while it is not warm. If the pump works. So switch on, switch on. No, we can't. Here I press the button while it's not warm, it doesn't switch on. So it's something I didn't understand. So let's draw how it works, although it is not that important. For our planning, I'm interested to see how this works. So let's switch this off. We don't have any power going through. This is off. So we have AC. We have live. We have neutral. Let's say it passes. We don't care about this, so we say this is enabled all the time. So it goes through the resistance, up, 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 heating resistor, and from the heating resistor there are two thermal. I'm not sure what the symbol for thermal fuse is. Let's just put a symbol with fuse, 1 and 2 fuses. These are the 2 fuses. After the 2 fuses, it goes through. This is neutral, right? Yeah, it goes through neutral. This is one path, so it only heats up when the 2 fuses are on. There's another branch which is here. This is going to the switch. So there's an LED. The LED is always, it is on when it is. So I don't understand how this was exactly. Then there's a switch, and the switch is connected to neutral also. No, can't be. Ah, the neutral is for the light to be on. There is something connected to neutral, yeah. And the pump is also connected to neutral. So let's have the pump. I have no idea what the symbol for pump is. I'll just put M like motor. This is on one side connected to, so the red one is connected to neutral, up, and the black one is connected to this wire. I think it's this way. And the neutral is just for the LED to be able to go on. Yeah, it's just for the LEDs to be on. So this is the LED on, and this is probably the other LED. Okay, so the pump, wait, so when you press the button, it still warms up this thing. Does it? No, there should be only power. There should only be power when this thing is switched off. So when it is switched on, it goes here. When are they just relying on that? And when it is warm, this path is cut. It means that it only can take this path now, but it also means that this path should also be here. But it's not. I don't understand how this works. Why isn't the pump working when this switch is on? This is a more direct connection, but still, isn't it enough to also power this? It's not enough because this is also requiring 230 volts and this is probably then not enough power. Oh. There's not enough power to go through this. No, that's not true. Through this resistor. Okay, I don't understand it. There's something wrong here. I'm missing something. This is after the resistor, so the pump is always after the resistor, but the resistor. Let's see. Okay, there's something I didn't get. What is this doing? What is this thing doing? Let's switch. So when we press the button, what is it contacting? I would expect black and red. That would be my guess. No, it's not black and red. It is plugged in. Let's unplug this just to be on the safe side. Come on, I just want to probe. Okay, it is switching blue to red. It did, yeah. This is switching blue to red. Blue. Okay, then I understand even less. Blue to red. What? What? I don't understand. So let's test again. Live is going through brown. Brown, the rocker switch is enabled. There's nothing connection. The brown is always going through the resistor. This is the resistor input. Then there's the resistor output. We have the fuses, or it goes to the switch. This switch, is it activated? Let's see what's. This is on. Why would this be on? Okay, let's open the switch back. It's impressive how primitive it is, but it's still cleverly designed. And yeah, to keep the costs down, you directly switch mains. You just have to need, I hope these are double insulated cable. I would probably think though. Is it written on it? It seems like it. So what is what? 3 is yellow or blue. Damn it, it's the same thing. Five ohms. Everything is plugged now. What the hell? I'm not pressing any button. Why is red Let's measure resistance. Resistance between this. So first, no, we're going through, yeah, the red wire. This is what I want to figure out. The red wire is going to this. Silicon cut. 0. There's a tiny bit of resistance, but not a lot. Something I didn't understand. This is going, so this is, yeah, this is red. Why did they also add this thing? Maybe because the resistance, yeah, this is, it's red. Red is pin 3. This is going through, which color was it again? I would say the yellow. 40 milliohms. 42 and 40 milliohms. Something weird with this connector. Okay. There's something on this connector which is connected together. Okay. Why? So red is going to brown and not yellow. And it makes sense. Red, this is going to brown. There is, no, does it? Yeah. The brown is going through 2 LEDs. It's going through the red LED and resistor. I want to draw the resistor and to the green LED. Then there is a switch which is switching both together. This is the red LED is on yellow. Yellow. And yellow is yellow is pin 2. No, is it? No, yellow is pin which mark 3. Yellow is 3. Oh, this is 1. Yellow 3. And brown is 1. Ah, okay, the board, you don't see it here, but on this board there's 1, 1, 2, 3. And are 2 and 3 connected on the board? Don't think so. Is 1 connected to 1? No. Oh, here. Let's put the buzzer back. I don't want to read all the time. 1. 1. Okay, 2 is 2. 3 is 3. Okay. And here red actually. So 1, yeah, let's fill out again. What is what? 1 is this one. Yeah, 1 is red. 1 is the brown. Yep. Then 2, this is 2. This is blue. B is 2. And 3 must be the blue one. No, yellow. 3 is yellow. Okay. Now I got this. And 2 is going to black. Let's put this here. The black is going through the pump. Black here. Through the pump. Okay, so this is in line. And the yellow. Now I get it better. And the yellow is in the blue. Blue, BL, U, blue. And this is getting to, yep, this is going through neutral. Blue is neutral. Okay, so okay, so this is how it works. When power doesn't go through here because this is blocked, it will only go through here. But it will only go, so it's not going in parallel because this is the least resistance. All the power, all the energy will go here and there will be no voltage going through the red LED. Wow. Okay. And the green LED will only light up if you press because it goes back here when the red LED is on. But yeah, and the power goes through the green LED and the pump. Oh, the pump. There's a short somewhere. Something I did wrong. The pump, if you press on the switch, it cannot be to blue. Yeah, what I did wrong is probably find out between what is what the connection. I think this is between 1 and 3 actually. It's between yellow. No, it's between yellow and blue. Right? 1 and 2. No. It's between 1 and 3. 2 and 3. No, that's right. Between 2 and 3. And the other side of the pump. So this is, but the other side of the pump is going through the red wire. It's going there, and the blue wire is going to the black. It's going to pin 2. Okay, there's something I still didn't understand is how does the pump get power? Through here, but when you short that, why wouldn't the pump get power? The green LED, the pump gets power at the same time. Okay, that's the thing I still didn't get. This isn't parallel, right? Yeah, this must be in parallel. There's only one clamp. This is still warm. Afterwards, we will have a look at these two thermal fuses, but they are still pretty warm. This should be the right schematic. Oh, we tested that there is some connection between 2 pins. Yeah, why between 1 and 3? There is. If I put it the other way around, maybe there isn't. It's just because it's going through the LED. Yeah. If I do it this way, it makes beep. And if I do it this way, it doesn't make beep anymore. No, it does make beep. So 1 and 3 are connected together. Where? 1 and 3 are not connected together. They're connected together in the wire? One and 3. Ah, yes, they are. When this is... No, they are not. No, it is. They are connected together when this is powered. Does it make sense? 1 and 3. Ah, this is why the red doesn't go on. Ah, now I get it. Now I get this path. 1 and 3 are connected together. Ah, now I get it. Okay. And this is not neutral, actually. No, it has to be neutral. So how the red LED works, if there's no power going through, if this is on, the two potentials here are the same. So there will be nothing going through the red LED. When this is off, then it can go through the red LED. This is clever. Now, why is the pump on when I press on the button? Because it's connecting neutral to neutral. Or is it? Maybe I did something wrong with the pump. Here there can be power. Here there's power again. When this is switched off, there is power. So it can go through the motor using this, but it only when I press the button. Ah, there's wrong something here. I think this is not connected. This is brown. No, it is connected. Brown through the LEDs. But maybe the other way around. Let's test with the diode. Up. So, red. It doesn't switch anything on. Oh, these are not your classical LEDs. Are these? No, okay. These are the classical LEDs. And they only only work on one side, so they're only pulsing at 130%. So brown is the red LED, the LED is the other way around, the red one. And is it the same here? Yeah. And it's the same here. This is still true. Ah, this blocks. They're using the LED to block the current. So this connects when I press on this button. It connects this. No. That doesn't make any sense. It's AC, you have to think about AC, but still. Ah, it can't go through here and through the resistor? This is really weird. Why does the button press do something? So, yeah, the red wire is, no, the red wire is going neutral blue. Ah, I didn't put it the right blue. I did put it the wrong way. It's going through blue, not to this, not to brown. Black. This is black BL2. So this red wire is going to blue. Red, okay. Blue is the neutral, and then the black wire is going to the black here. No, this is fine. Still, if it's AC, why when I press on this button does it provide power here? There's power here because it's not going through here. And it's only using half of wave? But why on the why when I press the button does it activate it? I don't understand something. Okay, who cares? Here there are 230 volts, and so it does mean that blue, this blue and this red are connected, right? When I plug this in, blue and red are connected. When it's not heat up blue and red, it's 1 and 3. Yeah, blue and red are connected when it's not heating up. And when I press the button, then blue and black, these ones should be connected. Press the button. Yeah. No, the circuit is right, it's just my understanding which is wrong. So let's have a look at these. It's ridiculously simple, I still don't understand it. I think that this is a lower temperature and this is a higher temperature. This is normally, well, can check it actually. This is normally open until it's warm. Same here. No, because when it is too warm, this shouldn't be closing. Yeah, it should be closing. Okay, there's something I still didn't understand how it works, but let's have a look. Yeah, there's no, but it's not too important. There's no thermal grease or something like that. And up, if we look at it, 250, 200, no, okay, lost it. 1 and 2 screws, don't lose them. Here, this here it's written KDS 301, 250 volts, 10 amps, 250 degrees Celsius. And I think when it is under 250, it is pathing, it is normally closed. It's closed when it's under 250. And I think this is probably something like 400. When it's getting too warm and there's something wrong, this is the safety fuse additionally, but we'll check it out. Okay, no, it's something else. 150. This is KSD 301, but for 150 degrees. Ah, this is isolated. So this shouldn't be more than 150 because of the isolation and of the lag. Okay, it's still a safety switch. But it also means that if this is too warm, you can still activate the pump. And while activating the pump, no, you're not activating this thing. Yeah, there's still something I didn't understand how the circuit works. Maybe I'm thinking DC and not AC. No, I'm not. And they're using some AC trick. But what I would be interested in to figure out now is, can we connect it directly to the battery? I think not, because this pump is only working with AC 50 Hertz. I think it's pumped in at 50 Hertz. So if I put DC here, it probably won't work. We can exchange this pump against a peristaltic pump if we want to. But then we have also this resistor. And if I measure the resistance of this resistor, let's go to the resistance. This is probably where we will see the at 400 watts. How do I measure this resistance between this one and this one? No. Why no? Because it's plastic. Okay, the resistance is 120 ohms. Something like 120 ohms. 120 ohms. Does it make sense? So we have P is equal R I squared. We don't care about the R squared. We don't know how much current will pass through. But we can figure it out using this. So the current is equal to the 230 divided by 120, 230 volts AC divided by 120, it's, let's say, 0.5, no, 2, sorry, 2. So we have 2 amps, which makes sense because we are using 230 volts and we will measure 500, something like 500 watts. 430, so it's 2 amps which is going through. This is why 120. The problem is that if we are using directly with 48 volts instead of 230 volts, we will have only less power. It's 230 divided by, let's say, 50, it's 0, it's 5, so it will be 5 amps. No, this is only about the power. It's 5 times less. So instead of having 480 watts, we will have 5 times less. We will only have 90 watts. So we cannot use directly to battery. Or we could actually use the battery. It's just this would take a lot longer to heat up. It will use less power for sure, but it will take a lot longer to heat up. And the other problem is we would have to change the pump. So let's not do that. And instead, what I did, and it also, changing the pump would be a bit more expensive. What I did, thinking about that, is something like just use an inverter, which I've ordered especially for the 48 volts. I didn't know what I would use it for because I just wanted an inverter. I think I tried it and it works, but that's all I know. What we will use is this to set up to 230 volts because of the fixed resistance, and this way we still have 400 watts. This is for 2000 watts peak, 1000 watts not peak, 48 volts input, 220 volts output. Plenty to gen for that. So we will try this out if it works. Let's put this back together. Up. I'll still have to figure out a way to not have AC, although I understand how this works yet, and how to not have AC on the button if I have a remote. And I already lost the screw. Where is the last screw? Yeah, here is the last screw. Okay, this is ready to be used, and now instead of having it to this mains, I'll have it here. This, it will be completely isolated, but what I need to do is connect plus and minus here. Do we have some kind of connections? Yeah, I need to build another one. For now, we will just use this connection. It's a bit of a shame to have it to unplug it. Let's use this. No, I can't. Yes, I could. Do I want to? I could have this connection. I still no. Does this allow me to send? Yep. Let's use this connection. I won't use this anymore. The 300 watts. Oh, sorry. I will use this connection. I won't use this anymore. Up. This goes to the battery, and this will go here, red to red, and this is probably not long enough between these two connections. Oh, it is. No, it isn't. I have to cut a bit more. I did have a nice thing to do that. A plier. Where is this? Here. This to strip some wires. I don't use it very often, but sometimes, like here, it is useful. And cutter. Here's my cutter. Slice this. One, two. Okay, we have a bit longer cables. This should be minus. Yep, this should be plus. What I will also need to do, so here we have 48 volts. This is the connection to the battery. What I need to do is plug the CAN. This is the CAN connection to inject the messages. Up. Up. So this should go, this should be, which one is ground? This is ground, this should be ground. Black should be ground here, this way, which should inject, yeah, it should be the right way. CAN messages, I need something to power that, because previously I had a lead which was from the transformer powering it. We don't have this anymore. So I will have a power bank powering it. That would be enough. And this will be isolated still. Just need a power bank. Power banks are here. Something simple. Up with a USB-C cable. I like this one. Let's test if the power bank works. Power bank works, and it is blinking, so because it's not managing to send CAN messages, and that's normal because it's not connected to the battery. Let's connect it to the battery, and let's put this one on top. Do we need to see what's inside? No, we don't. Yeah, let's not close it for now. Let's get the battery. Up. This should be switched off. It is switched off. Up. Battery, you're coming here. And I hope it doesn't make poof. It shouldn't. It doesn't yet. But this is not on. So now it's not blinking. So it's red on. It means that it sent the message. Reset. If I press boot normally, yeah, it sent the message. This should be fully on. And now so I don't need this. If I enable it, we should have this also on. Let's see. Yep, this is on. Power is on. There is no fault. I hate these connectors because this is not for the EU plugs. You have a socket to make it stable, else it's not very stable on these. What I could do is, and I will probably do, make a modified cable afterwards. We can use something like this, but probably not this one, because this fits nicely in the three things and is quite stable. And then we can have the IEC connector. So I just need to find a cable. I think I have one of them still with this side on one side and the UK plug on one side. And no, I don't have it anymore. I'll probably find it somewhere. UK plug on one side and IEC on the other. What I want to do is have something in the middle. We don't need, actually there's no ground here, so we could use something like this with these two leads. We don't need any ground at all. But let's test it with the EU plug for now. If we plug it, it says 0. Can I push? Yeah. Function 50 Hertz, and this one says 50 Hertz here, and this one says 51.5. I'm not sure which one to believe. We don't care. 230 volts or 220 volts. Functions, let's go back to the watts. And if we plug this in, let's test if the battery is capable of powering 230. If capable of powering, I can't show it to you because I have hands on. Here, if I test on this side, on the mains, if I just touch on one side, there's nothing happening because this is not referenced to Earth. This is completely floating. This is getting warm. Okay. I have to plug the plug in. The fan here is already on. I don't know what, because I'm not using any power. Fan is already on. Something here won't is stable. So now I can enable this. Oh, this is making a lot of noise, but it is drawing 413 watts, 50 Hertz, 420 watts. The battery is fully capable of delivering it. It's not stopping. But what I will do is build this somewhere around inside here, probably. Could be inside here. Yeah, could easily be inside here. Let's wait until it is warm. Fan is quite noisy, and oh, it is dropping in hertz though. Now we're at 49. And I'm sure this is not a pure sine wave. We absolutely don't care about pure sine wave. This transformer, it's probably looking horrible. I bought it for, I think, 25 euros. I think somebody made a mistake on the listing. I don't think it should be sold at 25 euros, but at least at 2000 watts for 48 volts. I got it for that. It is getting warm, but it's okay. It is loud though. Although it's not too important, it will be outside with plenty of music or something like that. It is taking a bit longer to get warm, maybe because we waited a bit longer. But let's wait until it is on, and let's switch the fume. I think there's still something in the pump. Hope so. Let's put it back. We probably will hear when it stops after the wires. Yeah, they're not getting warm. They're fine. Ah, this says red and this says 0 watts. This is still making fan noise because it's loud. You're probably hearing it on the microphone. Yeah, you're also hearing it. And now if I press on the button, yeah, it works. Is the other yeah, the other camera is working. So this will be our portable solution. What I will do is, let's switch this off. This is still making a lot of noise. This fan is really noisy. I'm not sure if it's required. Yeah, I think it is required. Will it go down afterwards? I hope so. What I will do also is build in power meter. Do we have one? So it looks nice. Voltage meter AC. I should probably still have one. I have plenty of them. I have several of them actually. I have choice. We can choose which one we want. We have 3 AC meters. This is noisy. I didn't expect it to be so noisy. Ah, I can switch it off. And it switches off the noise. That's nice. This is weird though. You switch it off and it stops the fan. If I switch it back on, does it go full fan? Yeah, the fan is completely enabled. I will build one of these meters inside to see. Oh, this is actually too high. I can't use this one. This is not too high. The problem will be that if I plug it in, I cannot lift it without having the wires. No, that's okay. I can still put it on here. Either this one, which looks nice because of the 7 segments, or this one, which looks modern thanks to the LCD. I'll probably use this one because I have 2 of them. And although this is yeah, I'll probably use this one. This one is a tiny bit smaller, but it doesn't look fancy enough. I want to see something with a display. Oh, put it on the side here. Yeah, I'll put it on the side here. This one is huge, but this is inline. Ah, this is on it without a coil. This is with a measuring coil, something like this, where you put the wire in. This one is right here. And what I will try to find out is an IC cable with a UK jack, so it fits and holds inside here. This is not enabled, so we'll put this one on. See, these are very useful because they are quite robust in there, while AC is not that robust, and US even less. See how it's wobbling. I hope I will find a UK plug somewhere. Yeah, this is wiggling all around. Even if earth is not used, I'll still would like, so I can switch the battery off. The battery is fully capable of powering this device. This can we put this on the side? No, this is still too large. Up. So either this one, because this one is small. Yeah, I'll probably get with this one. This one looks nice because of the yellow, of the red lights. I can't put it here because this gets too warm. This will get flushed. I could put it here. This is not too warm. I'll have to make a hole on this side, but who cares? And then we can see when it is drawing. Although it's not that important. It just looks fancy. And we know actually, no, it's not that important. Why would I? It's just because I have them, I can put them. Oh no, I know why. Because I want to measure how many kilowatt hour are used. Does this in the end? And then I can reset it. Does this show kilowatt hours too? I never used this one. which one is it? PZM06 apparently. And does it remember the kilowatt hours? Up, down, function. Doesn't say anything. Watts, hertz. I have no idea. We'll test it out. It can measure the current, can it measure the kilowatt hours, and can it remember it? That will be the discrimination. This is too big. If this measures the kilowatt hours, we'll use this one. If not, we'll use this one. Let's try that out. The battery can be put aside for now. It's heavy. It's 6 kilos. 1 to 100 amp. Will be only have 5 amps. These two wires. Where is this? Oh, and there's something else I want to test. This will be portable, and I don't want to lift this. I only want to have a hose. What I don't know is, can I use a thin hose and it will still work, or do I have to use a large hose? We'll try that afterwards. For now, we will try this. And I just want to provide AC actually, and test if this works. I should have an AC plug here. Just an AC plug, and this is on off. Let's double check. Check. Yep, AC is going in here. Else we'll just make poof. Just not that important. Yeah, I want to measure how much kilowatt hours we have with a battery charge, or how much it's used and so on. So we'll have an energy meter built into it. Let's plug it in here. Switch it on. Switch this one on. This is on. Amperes up. Kilowatt hours. Okay. Now we want to try if it remembers the kilowatt hours. So let's switch it off. Switch this one off. We will put the whole. Yeah. Let's unplug. No, we don't have to unplug this. It's plugged nowhere. But we can plug it to the neutral, or even to the live. We don't care. Neutral, because there's more space. Let's unconnect this. It's gripping too much. Damn it. I don't want to ruin isolation, although it's just a shrink cable. I have plenty of them. Wow. At least this is holding quite well. Okay. So let's put this in middle. Actually, we can keep the coil even if we change the power meter. So let's just put it in here. We will probably glue it down. Afterwards, what we need to do is also change the connections, because we need also power for this one inside. This is just a test. It's not correctly put inside here, but just for the test, it should be enough. So this is off. Where is the power socket? It's here. Let's plug this in. Let's switch this on. Let's switch this on. And if I switch this on, we should see the current. Watts, 440 watts. There's a timer. Since when it's on. Okay. 221 volts, 2 amperes. That's fine. Kilowatt hours. The resolution is not that fine though. Is the resolution on this one a bit better? Probably. Maybe this is a bit better. I'm not sure if this will. Kilowatt hours now, is it good enough? We'll see. But Yeah, the LCD is not that funny. I prefer these 7 segments, although they flicker a lot on the camera. 5 watts. Okay, didn't measure anything. 230 volts, amperes 0, kilowatt hours. Let's put some fume. This needs a bit more of this, so it uses energy. Plenty of fume. Does it? No, it's still using 3 watts. Nope, it's not getting any juice anymore. Ah, the pump is using 10 watts. This is not written how much is using. My flat is getting fumed. Yeah, 400 watts. Okay, now it's getting warm again. Ah. Ah. 1 amp. 0.2. We'll see if we unplug it, if we replug it, if it's still 0.2. Then it remembers. So let's switch this off. We can also switch this one off. Let's switch this one on. 0.2. Okay, it remembers. This is stored in flash. Is this higher precision? Let's test it. So this is off. This is on. This is off. Up. Let's try with this one. Up. These 2 connections. And actually this has a serial output. I might use the serial output to have a nice display on the arm. So I might use this, is even more important. I might use this. Yeah, I'll probably use the serial output. So 1, 2, and we'll probably use this module. I have 2 of them. I'm not comfortable, even if power is on 2 sides, I'm not comfortable touching mains without unplugging. One, 2. Let's put also the coil. It's probably the same coil for both models. This is, yeah, also 100 amp, so it's probably a 100 amp hour coil. Is all the coil in the package though? Yeah. Is it written somewhere? No, it's not written. The color is different. I expect it to be the same coil. We'll see. Once we connect to it. If we see 2 amperes, we know it's the same coil. And I'll warn you, this is very flickery. Power. Power here. Power here. Power here. Yeah, it has 1 more digit. And is it flickery on the camera? Yeah, it's flickery on the camera. But to the eye, it's not that flickery. And we don't have to press a button yet. The display is less large, but we don't have to press a button and we see everything at once. I prefer this one. And I'll even probably connect this to measure it and to have something on the handle and to see how much it uses and so on. Let's switch this on. and we see 0 amps. Is this still warm? I don't believe it. This is probably not the right coil, or it is not connected correctly. No, it is connected correctly. Is this a different coil? Oh, this is connected correctly. Let's put this measuring device in between, because I trust this one. You won't see it, but I will. Okay, you can probably see it a tiny bit. So 0 amp. No, okay, it has 0 watts, so this is still warm. We'll blast even more. So let's enable this. Kilowatts, so we can even see watts. So if we press here, we should see something like 15 watts. Yeah, 15. Let's put even more. Okay, 400 watts, and here we see not the kilowatt hours increasing, but we will see it afterwards. Yeah, here we see it. Okay, definitely this meter, definitely. The problem is I will have to put it on the side, which is not too much of a problem though. I'll have to put it on this side. So we will use this. Now the last test I want to make before we close the stream is, can I use a thin hose? Let's switch it off. Can I use a thin hose in here, and will it be able to blast? Or do I have to use something larger? Do I have a thin hose? I think I have one. Don't know where it is. I'm sure I had one. Where did I put it? Here. That's not the one I was thinking about. No. Should be able to work, but it's not the one I was thinking about. Oh well, let's try it with this one. Damn it. Come on, come out of here. It's not meant to be taken apart again. Let's get some scissors. Up. Okay. And it's probably long enough. Here, a hose. Will it come outside still as fume? I have to pay a bit of attention because this here is a piece of metal. Let me show it to you. Switch off. Here there's a tiny tube. I think this is the tube which is pumped, which is still warm. So whatever I do, I have to be aware that this shouldn't be switched on. So we will try if it's switch. So this on, and if I press on the button, does it work? Whoa. No. Okay, this works. Why is it vibrating? Okay, but no. But yeah, it's not coming outside correctly. All the heat is getting here, and then it's cooling. So we need a large tube. I have a larger tube. How large do we need it? Let me get the larger tube. It should be somewhere around here. That's probably not enough. I'll still have to have larger. Probably have to have extremely large. So we have this as large tube. This is from, no, I can't use this one. This is from a washing machine. There is a filter on this part. There's no filter on this one, but it's probably even not enough. I will probably need a very large tube. and it's probably that long, so if it comes out here, then we know it works. So let's try it out. This is one side, the other hand is on the other side. Let's test it. It works, but I think we're losing a lot with all this pressure here. There's only a tiny bit coming out. What we could do is have a fan mounted here, which also blows everything, which adds, and this is probably what I'll do. I'll just have a fan on top here, which blows everything inside. And put some more air than just this. We still need something larger than this. This is not enough. I'll put a larger out. But the idea of having this flexible tube is worth it. That's fun. This flexible tube, yeah. Okay, that's all I wanted to test. Now I know what I need to order. I know that I will need to put this inside here. And probably the best thing is just to have the tube mounted here. Could be, yeah, it could be large enough. It's just short. This will be on the backpack, and then we'll have something on the hand, like something like a gun, or which sprays everything. Switch this off. Switch this off. But we have the concept. We'll add this. We will add probably a fan. We will add a hose, a large hose, still flexible. The battery works. We have to use the inverter. The inverter is a bit loud. But do I want to change the fan? Or do I want to enable to open the device and see what it's doing? Meh. For now, let's have it loud. The pump is also loud afterwards, so we're fine with the thing being loud. That's it, actually. Now we know what we're missing and what we will be building. And I need to fix everything on some kind of board or something like that. That's for another point. For now, the stream is complete and we know what we will use. Okay, so enjoy the rest of the day or the evening. Bye bye.